Good afternoon, everybody. Thank you for joining today. We're just going to wait probably 30 seconds or so, and then we'll kick off. Just while we're waiting for everybody, just a little bit of housekeeping. So the cameras have been disabled today, so they won't be on, and similarly the voice function as well. However, you'll be able to see the video afterwards. We won't be sharing the slides, but it'll be available on our website once we've finished. And also you'll note within the webinar there's a chat function. So as we go along, if you have any questions, please do drop those into the chat function, and what we'll do is we'll come to those at the end and make sure we get those answered. So brief introduction. So my name's Pete Best. I'm a member of the client management team. So I'll do a short sort of overview in terms of AES and who we are. And I'll then hand over to Rachael Collins, who's a senior Passivhaus consultant here. She'll cover the technical detail around Passivhaus, and we'll close with questions via Fayworthy. He's also in the client management team. Do you want to pop the slides up? Thank you. Oh, Rachael, do you want to pop the slides up?
Yeah, I can do. Sorry. Sure.
Perfect, thank you. So this webinar is episode 3 of our series. So we've had 2 already, which you can see on our website if you want to go back and see those and you haven't seen them already. And this one is Passivhaus and Introduction, the what, the why and the how. So we'll go through a brief overview of what Passivhaus is and the key requirements of Passivhaus, also the benefits and the regulatory influences, and then a quick insight into targeting standards. Thanks, Rachael. A little bit about us then for anybody that hasn't been on the previous webinars or isn't aware of AES. So AES, we've been around for a long time now. So started in 2005, so over 20 years in business. We just recently celebrated our 20th anniversary. We've grown organically and rapidly in that time, and we've now reached the size that we've got over 130 consultants. So we're growing very quickly, and we've got expertise which covers the entire spectrum of sustainable development. So whatever it might be, if you're doing a development project and you need help, then we're able to point you at an expert that would be able to assist you with that. So we've got industry leading expertise across the board. Along the way, we've worked with a lot of the major developers, so most of the top 25 house builders, including developing specs for some of the top PLC builders. We also have a sister company as well. So as well as consultancy works, we have national coverage where we're able to offer testing services. So things like air tests and sound tests and so on. Thousands of projects that we've completed, and also we've picked up lots of awards along the way. So a couple of examples here. We've picked up BRE BREEAM awards. We delivered the first UK's Home Quality Mark scheme, which is rebranded as BREEAM Residential. And then most recently, just last year, we picked up Product of the Year at the House Builder Awards, which was for our AES Hub and Site View, which is picture evidence capture and data capture for development projects. So that's a little bit about us. Next slide, Rachael. Over to you.
Thank you, Pete. Hi, everyone. So yeah, I'm Rachael Collins, and I'm just going to give you a brief overview of kind of who I am before I launch into the presentation. So I'm an expert in Passivhaus, particularly I specialise in new build residential development, which is the most common application for the standard. I have, however, worked on a wider range of sustainability projects, so including looking at Passivhaus within school buildings and office buildings, and in both new build and retrofit spaces. I lead the AES Passivhaus services here, and I have been certified Passivhaus designer since 2021. So let's get into it. What is Passivhaus? So Passivhaus is a leading international energy efficiency and comfort standard, but it's more than just this. It's kind of a high quality design standard that provides people with kind of quality living conditions, both in the home and kind of at places of work, and avoids the usual performance pitfall gaps. It was born out of an interest in building physics, so originating in the early 1990s, and has evolved into an international building methodology with rapid growth over the last decade or so. And I think this has mainly been aided by our increasing awareness of the climate challenge and the need to dramatically limit our energy and carbon footprints. The graph on the screen shows the quantity of certifications under the Passivhaus scheme worldwide. You can see the vast majority of these are in Europe. There are also kind of growing in the Americas and Asia as well. So it's really important when we're speaking about the Passivhaus Standard to emphasize, although it's known for housing, it's not just a methodology applicable to housing. It's been developed to be relevant to any building type. So, that can cover schools, offices, hotels, and leisure centres. You perhaps have heard of St Sidwell's Leisure Centre in Exeter. That became the UK's first Passivhaus leisure centre. The standard is successful across a range of building types due to its focus on reducing energy demand and improving quality in construction, but also, as I mentioned, in the internal environment that it's delivering. There's a few images on screen of some more of the famous Passivhaus around the UK. So this includes the award-winning Goldsmith Street in Norwich, so mainly terrace housing. We've got the apartment blocks in Agar Grove in London, and then the Harris Academy, which was, I believe, the UK's first secondary school built to the standard. So when we talk about Passivhaus, we're normally talking about the Passivhaus Classic standard, but there are different strains of the standard. So there are also the Passivhaus Plus and the Passivhaus Premium, and these basically take the Passivhaus standard and they also incorporate the requirement for renewable energy generation. So for the Plus, that's 60 kilowatt hours per meter squared a year of on-site renewable energy, typically from rooftop PV, and Premium, that's twice as much as that. Lastly, the Passivhaus approach can also be applied to existing buildings, and this is known as the Enefit standard. The Enefit standard follows the same principles as Passivhaus, but it does have relaxed targets for space, heat and demand, air tightness and total energy use, and that's to reflect the realities of having constraints with existing buildings. So now I want to move on to kind of what are the key requirements of Passivhaus, which I've put the main ones on screen. There's a lot to the methodology, but these are the main targets we're trying to hit. And potentially the most famous one is the space heat and demand target set at 15 kilowatt hours per meter squared a year. For a bit of context, a new build detached house built to Part L 2021, you would expect the space heat and demand as measured in PHPP in the Passivhaus software to come out around 50 kilowatt hours per meter squared. So, that's 3 to 4 times higher than what Passivhaus is aiming for. There is also an alternative criteria. So you only have to meet one of the 2 top criteria. So that the alternative to the heat and demand is the heating load, and that is set at 10 watts per meter squared. For our projects, we tend to start by targeting the space heat and demand, and then we kind of use the heating load as a backup if the project, just falls short. An example of where heating load kind of comes into its own is for dwellings that are constrained with their orientation. So often houses that don't have much south-facing glazing, so can't take advantage of that passive solar gain in the winter, they will find it easier to certify under the heating load route. Passivhaus also has a requirement for cooling demand. This is 15 kilowatt hours per meter squared a year again. Historically, this has not been kind of hard for UK housing or other buildings to meet, but obviously it is becoming more relevant as we become more aware of the overheating risk of our buildings. The total energy use target in Passivhaus is called primary energy renewable, and that target is set at 60 kilowatt hours per meter squared a year. Now, it's really important to remember that Passivhaus does look at both regulated and unregulated energy, so you do need to take into account all the energy use used within the building. Moving on, I think the most feared criteria is the air tightness, and you may have heard the air tightness target is 0.6, but that's air changes per hour. So the Passivhaus air tightness is measured slightly differently to building regulations. For a individual home, 0.6 air changes typically works out at the same as 0.6 to 0.7 air permeability. So that's easy enough to remember. As the building scales, the air permeability will change to meet that 0.6. And then finally, but still very important, is the overheating criteria. And passive house homes must ensure that no more than 10% of the hours have a temperature above 25 degrees C. However, to achieve certification, often the reviewer would require an improvement over that. So typically they actually ask for about 5% to make sure, we are avoiding that overheating risk. So that's kind of a quick overview of what we're targeting, but why would we do this? I wanted to give a bit of background of kind of the main benefits of targeting passive house on your project. And I believe there's probably 4 of them. So the first one is energy efficiency, unsurprisingly. So the standard demands very minimal energy use, and it is a fabric first approach. So it enforces, as I mentioned, low energy use throughout the building, covering both regulated and unregulated energy. And this obviously has knock-on benefits for both the occupant themselves and also society, with the opportunity for the building to be more self-sufficient and less demanding on the electrical grid. Secondly, occupant comfort is key for the standard. It focuses a lot on indoor air quality via the requirement of constant filtered mechanical supply of air that delivers more stable temperatures and also helps prevent condensation and drafts. Then there's affordability. Probably goes without saying, but low energy use means lower bills for the occupants or the landlord. Therefore, passive house is particularly advantageous for schemes where fuel poverty may be a key concern. And then finally, but not least, is the construction quality. So the passive house methodology includes a lot of emphasis on quality assurance and checks on site. This helps eliminate the performance gap and produces robust buildings that are made to last. I've also got a nod on screen to the climate emergency as obviously a higher, more holistic driver behind passive house and similar energy efficiency schemes. So the climate emergency isn't going anywhere. And that's, we need to be part of the solution. So as well as kind of all those kind of key benefits, there is actually now a bit of a policy drive supporting some implementation of the standard. And I've got a few examples on the screen, and this normally now crops up in local plans and particularly emerging local plans as well. So some examples are for areas, some areas, new council-led housing, it is mandated to meet passive house. So that those, for example, are Exeter and York. Then the South Downs National Park Authority goes one step further. They actually require now in the current local plan that 10% of homes in major developments must meet passive house certification, and they must be certified. We also see passive house now used as an alternative path to compliance. So an example of this is in the draft South Warwickshire local plan, where rather than meeting, I think it's about 63% carbon reduction over Part L, you can instead choose to have a passive house certified route for compliance with the local policy. And then there are other schemes that are kind of more, I see as passive house adjacent. So many local authorities have set higher sustainability targets within their planning policies that look at things like space heating demand, total energy use as well, and then renewable generation. And they normally require that the evidence is based in PHPP, so the passive house software. So you need to do passive house modelling to evidence kind of these targets are met, although you don't have to get certified. And a few examples of those local authorities are Bath and North East Somerset, Cornwall, and Central Lincolnshire. And then also just to mention, the GLA now have an ambitious space heating and EUI target for all projects in London, and that also closely aligns with kind of passive house levels of efficiency. So that's kind of policy at a local stage. But on a larger scale, you may have heard that the Scottish Government are now committed to introducing their own passive house equivalent standard for all new homes built in Scotland. Now, the details for this are still under consultation, so we don't know exactly what metrics and targets will be required or how this will be implemented at the moment. However, last I checked, the commitment is to publish the standard early next year, and then the implementation date for the standard to come in is set at the 31st of March 2028. Can't get that number out. So we've done the what, we've done the why, so now we're moving on to how do we make our projects kind of Passivhaus compliant? So the exact specification you would need to get to Passivhaus certification obviously depends a lot on the specific project, on information such as the location, because local climate files are required in the modelling, the orientation to depend how much solar gain and loss there are, but also very importantly, the density of the dwellings. So number one, when we start on a project, we kind of reinforce that simplicity in the building and in its form is key. Buildings with larger volume and internal floor area compared to their surface area inherently lose less heat. That's just physics, but we can use it to our advantage. We often talk about the form factor of a building, which is the ratio of this external surface area to the treated floor area inside. And the smaller the ratio, the better for energy efficiency. So in practice, this means designing simpler buildings with less protrusions. Also means that, designing apartment blocks or terrace housing over individual homes can help you meet the standard. So the image on screen shows the form factor along the top for different shaped buildings with an estimated insulation thickness you need in that external envelope to achieve Passivhaus along the bottom. And you can see, an apartment block might only need 150 millimeter of insulation compared to 300 plus for a detached home. If we kind of take a step back and think about the project timeline and how we kind of slot Passivhaus into this timeline, it is very important to get in there early. We always say this, we kind of want to start as early as possible along the REBA stages. At REBA stage 0, that might just be that the Passivhaus is set in the brief from the outset, so everyone knows the ambition. And if at all possible, we really like to get involved from REBA stage 1. The Passivhaus consultant at this stage, we can run introductory workshops for the project team, but also get involved in some initial site analysis, looking at that layout and orientation and kind of help discussing with the key members of the design team how we can maximize our advantage to moving forward to targeting Passivhaus. At the concept design stage, this is when you need to have a Passivhaus consultant on board, and Passivhaus modelling should begin. So the modelling is, as I said, undertaken in PHPP software, which is an Excel-based tool. So at concept stage, the initial models can support the emergent design and also provide some feedback on how different forms or different design choices might enable the building to perform. It's also important at this stage to start the appointment process for the Passivhaus certifier. Now, the Passivhaus certifier is an independent third-party consultant, so different from the Passivhaus consultant, who will ultimately use their professional judgment to decide whether the building, once complete, achieves certification. So they will have less input at each stage, but they need to be on board to undertake some design reviews and then the final test at the end. At stage 3, a more detailed PHPP model begins to emerge along with the chosen design. And throughout this, we'll be in constant liaison with the architectural and engineering teams, checking that the design can meet the desired U values. We support on heating and hot water system choices and optioneering. And then we also advise on air tightness strategy and materials. And this continues into stage 4 and technical design, where we start collating the in-depth evidence we need for certification. And we also discuss things like the air tightness testing regime with the team. At stage 5, the Passivhaus consultant is also really important. We can support the construction process via regular site visits, including delivering toolbox talks for the subcontracting teams to make sure everyone's on board and everyone understands, the importance of the insulation and the air tightness and, other passive house issues. If there's a deviation from the design at this point, which there often can be, we will need to update our model to kind of reconfirm compliance, and we can help troubleshoot and find solutions if the performance dips but below the level that is required. And we will also support the final air tightness testing and ventilation commissioning. We then submit the final PHPP model and all the collated evidence to the Passivhaus certifier for the final certification review, which hopefully results in the good news of a pass. And then, moving forward, stage 7, there's no ongoing work required for Passivhaus, so no post-occupancy monitoring is required. But we obviously encourage that, there is some feedback loop that clients take from their projects to provide the opportunity for learning. So just to call out, I've tried to indicate on the slide where the independent certifier will get involved in the project. So that's a definite at stage 4 for the full design review. At stage 6, once the project is complete to certify, but then often the certified will want to have done an earlier design stage check. So this is normally around stage 2 or 3, and that's, hopefully prior to planning, just to make sure that everyone is aligned and they think we're on track for an easy certification. So I guess this is more of the nitty-gritty of so how do we deliver this in practice? And I've got 6 key design principles on the screen for you. So to start with, yes, Passivhaus is a fabric first approach. So high levels of insulation are key. Passivhaus is construction method agnostic, so you can take any approach. That could be traditional masonry, timber, steel framing. It can all work. But the real important thing is there's a continuous insulation layer that surrounds the whole of the heated space of the building, and that this insulation layer retains its performance as much as possible and thickness throughout. So at early stages of design, it's good to factor in the correct construction depths, as these will likely, particularly for the walls, to be thicker than for a normal build. So for example, if you were kind of using a masonry construction for a house, that's likely to be a cavity of 250 mil plus of mineral wool. And, the total wall depth could get up to around 500 millimeters. So for our insulation, we're typically targeting U values of around 0.1 to 0.15. Again, it's building dependent. So for an individual detached house, you'd probably want to be down at the 0.1, whereas if you're doing a larger apartment block, so for example, at the moment, we're working with Barratt on, I think, what may be the second largest development of Passivhaus in the UK at the moment, and that's in London. And for that, we're targeting a U value for the walls a lot closer to 0.18, so a lot closer to kind of notional building regulation, because they are larger buildings and they retain their heat better. So number 2, a balanced window design. Optimizing the window design is very important. Obviously, from a U value perspective, they are always going to be a thermal weak point in the external envelope. The U value is going to be several times, 6-8 times higher than the wall. But they do allow entry for solar gain, which is beneficial over the winter months. And so we want to orientate our dwellings so that we capture as much of that as possible, whilst also avoiding the risk of overheating. So we do typically advise slightly larger glazing areas on the south, and then smaller on the east, west, and north. And again, the PHP can be used as an iterative tool to kind of tweak the glazing areas and find a happy medium for all these for all these different requirements, along with overheating and daylighting. And before I move on, I must emphasize that triple glazing is required for a passive house. So that's, a key difference potentially to what you may be building with for building regulations. Number 3 on our design principles is mechanical ventilation with heat recovery. So all passive house buildings have to incorporate mechanical ventilation with heat recovery. And this is driven by the need to meet both the energy and the comfort criteria. So for low energy buildings, ventilation losses end up becoming a rather significant amount of heat loss. So the ability to capture and reuse the heat from the air leaving the building is crucial to meet that 15 kilowatt hours per meter squared space heating demand. So this is different from recirculating air. It's only the heat of the exhaust air that is captured itself. There is also a bit of a myth that passive house buildings, you're not allowed to open your windows, which is totally untrue. The MVHR is there to provide constant, continuous background ventilation. But, you know, if you want to open windows, that's fine. The user can use the building as normal. At the early design stages, it's really important to understand where this MVHR system is going. And that's because the ducts to and from the atmosphere, so to and from the outside, are lower in temperature than the heated space and do prevent a source of heat loss. So ideally, we need that unit to be situated alongside or as close as possible to an external wall. So that's just something to keep in mind. Number 4, minimal thermal bridging. Now, the junctions and connections between elements provide a thermal conductive bypass route for heat loss. And so to achieve passive house levels of performance, we need to minimize these as much as possible. We often talk about a passive house being thermally bridge free. In practice, it doesn't have to be completely free of thermal bridges. We just try to minimize them. And there are always going to be some that, you know, that will remain. The psi values calculated for a passive house model do differ for the ones used in SAP, as they use different dimensions. They use external or internal dimensions, but it's a similar process and the same methodology. So to get your passive house certification, it requires all thermal bridges have either been judged by the certifier as bridge free, or there's a psi value calculated in the model for them. So number 5, exemplar levels of air tightness. So yeah, as well as that continuous insulation layer, passive house requires a continuous air tightness layer encapsulating the conditioned space. And as I touched upon earlier, this is measured in air changes per hour at 50 pascals. And again, it can be measured via the blower door test. So an air tightness of 0.6 is challenging, but it's very achievable. And what I like to remind project teams of is you're not really actually having to do anything different from a typical construction. You're just having to do it better. And yeah, just look at those details a bit closer than normal. And actually, we find that most people take real pride in their work on site and are quite up for the challenge. And then number 6, this one can often be forgotten, high energy efficient lighting and appliances. So in order to achieve the total energy use, which is the primary energy renewable target value, it is wise to incorporate a heat pump system, as these extract free heat from the environment and therefore, you know, have coefficients of performances greater than 1, so typically, you know, 2.5 to 4. However, this is not sufficient on its own, and often at early stages of design, we can forget that by the end of it, we need to account for all energy use in the building. So this needs to be minimized. So we're probably looking at LED lighting. If you're putting in any appliances or white goods, you know, looking at the energy label of those and checking their, you know, their reasonable high. So probably C upwards. And then obviously unregulated energy behavior is down to the occupant. So we typically use default values in the passive house model. But if there is anything to be installed that's slightly different from normal and it's going to be installed by practical completion, it will need to be in the model. And finally, I would be amiss if I didn't mention again the need for on-site monitoring and testing, which is arguably the most important part of the process, as it ensures that what we build really does reflect the design and the expected performance. So we work really closely with our contractors to encourage a positive no blame culture on site. And this enables workers to be comfortable with reporting issues and we can correct mistakes together. So also for certification, there needs to be detailed evidence of the build process. So that's typically a lot of photographic evidence. and that would equal a passive house. So yeah, thank you everyone. I'm going to quickly touch on our next webinar episode. So there won't be one in August. We are taking a short summer break, but we will be back on Tuesday, the 17th of September at 2:30. At the moment, the episode for September is TBC, so undecided. We are expecting significant updates to both BREEAM and the home energy model. So, you know, we will tailor the session to bring you the most relevant updates we have at the time. And thank you.
That's great. Thank you, Rachel. So we're actually just about the half-hour mark, but we'll take a couple of the questions that have come in before we wrap up. So if you have any questions, put them in the Q&A bar. So the first one we've got is, within new developments, there is a concern regarding enhanced fabric performance and the impact on overheating. What design measures or advice would you give to enable a fabric-first approach with reduced overheating risk?
Yeah, that's a really good question. So yeah, there's obviously a lot more concern about overheating nowadays. So I would say that insulating doesn't necessarily exacerbate overheating. Obviously, it does limit the amount of internal gains that then can escape. But that's why, you know, the ventilation strategy is key. So the ventilation with summer bypass helps remove some of the air at constant rate. And then also we do look at that glazing design very early on to balance the solar gain against, you know, the other requirements such as overheating. And typically where we can shade windows, particularly to the south, you know, that's a normal go-to with overhangs. So yeah, it is kind of a key concern of ours now when we're looking at passive house projects, but we do make sure the design is holistic and we take that into account.
Great, thanks. And does the passive house air test differ to what is required for building regulation?
So yes, it does in some small ways. So they both use the kind of the blower door test, so that big fan that you stick in the opening of a door. But the passive house air test is measuring slightly different things. For passive house testing, it's still carried out by an ATTMA accredited tester, but they need to take both pressurization and depressurization tests, which I believe for building regulations, you don't have to do both. And then again, the output of that testing using the blower door equipment, you will do specific calculations off the back of that to get to the passive house metric, which will differ, but that will be done by ourselves, by the passive house consultant.
Thank you. We'll take one more. So what is the typical cost uplift in meeting the passive house standard over a typical build?
So yeah, I hear this asked a lot. And obviously it's really hard to say, and it's very project dependent. There have been some research done on this. And typically they are seeing a cost premium over typical schemes of about 8% to begin with. I think the Passive House Trust has updated their kind of view of this and saying, you know, nowadays it might be closer to 4%. And then Exeter City Council, actually, who have a lot of experience in passive house projects, so I think they've been doing them for over 10 years now, have claimed that they've now reached cost parity. Obviously, they've got a lot of experience with it. So I don't think you'll be there straight to begin with. So probably starting around the 8 to 10% mark, and hopefully, you know, as we all learn, that can be lowered.
Cool, thank you. So we have had one more come in. Are you okay to take one more?
Yeah, sure.
Do you think it will be difficult to deliver large-scale developments to passive house standards? And do you think it's something that the government will eventually bring in as standard after future homes, or something that is mainly council-led?
It shouldn't be difficult to deliver large-scale developments. I think there definitely has been less of them done in the UK, but we are now starting to see them crop up with kind of larger scale developments. I think the concern is the cost of certifying as well as kind of the design of that. And it depends on how many unique house types you're dealing with. Like if that larger scale development is a large apartment block, inherently, you know, it's easier to meet the standard from a space heating demand point of view. So you've already got that advantage. With the introduction of the Future Home Standard, I think the government is quite clear on their direction of where they're going with kind of energy policy in the UK. And I don't see them going down the same route as Scotland and kind of like leaning on Passivhaus at a national level, but I don't think it's going to go anywhere with the local authorities. So I think it will probably remain at the local authority level.
Well, thank you. So I think that brings us to the end of the Q&A section. So thanks for sending in the questions, and we'll make sure to follow up on anything we didn't get to today. So yeah, thank you all for joining.
Thank you, everybody, and we'll share the invite for the next one with everybody that's on here. So hopefully we'll see you in September. Thanks all.